Hey bio team. So biologists will often use light to measure biological reactions. And to do this, they'll use a tool called a spectrometer. And so I have a spectrometer here, and this measures two different things. It can measure the transmittance of light through a sample, that is, how much light passes through a sample, and it can measure the absorbance of a sample, that is, how much light gets absorbed by a sample. And so what's cool about this type of spectrometer is that it measures all the wavelengths of light in a spectrum. That is, it measures the absorbance and transmittance of all the different colors of light. So we'll show you an example of this here. We'll take our spectrometer and we'll take a sample of green dye. There's our green dye. And if we put the green dye into the spectrometer, what the spectrometer reading will show us is that green wavelengths of light are able to transmit through our solution, whereas all the other wavelengths of light are not able to transmit through the solution. And that's why our solution appears as green, is that the green wavelengths of light are able to transmit through it, and the other wavelengths are not. And if we change our readings from transmittance to absorbance, we'll see that the opposite occurs. We'll see that the reason that the other colors besides green were not able to transmit through the solution is that they were getting absorbed. And so you can see our purples and blues have a high absorbance in our solution, and our yellows and reds and oranges have a high absorbance. They were getting absorbed by our solution, whereas green wavelengths of light are not absorbed. There's a low absorbance for green wavelengths of light, and consequently they were able to transmit through. We were able to see them because they were not absorbed. And so that's it. At this point, you guys have a couple of practice problems involving spectrometry readings. We'll see you next class.